Hey everyone, my name is Susmit. So, considering that you all are hungry, let's start quickly. So, who am I? Well, I am a certified Neo4j professional. I am a full stack developer and data scientist. I recently joined Excellent as a senior data scientist and software architect. My first company was Tech, where I was a tech team lead. I am also a mentor at FuseBytes. And people always ask me about my engineering college, and I just get an exception. I haven't done engineering. I have done BSc IT from Digi Rupal College in Matunga. So let's see what the talks consist of today. We will go through the two simple approaches to recommendation engines. We will have a quick intro to Neo4j. First, a show of hands. How many of you have heard of Neo4j? 1, 2, 3, 4, 5, 6, 7. Okay, cool. Then we will go through a dummy case study which revolves around a restaurant app. Also, then we will proceed with a real case study which I work on as a freelancing project which revolves around a social gathering app. So, first the simplest thing, collaborative filtering. This robot is not GPT-6 enabled. So, considering that, till now we need human and human for the collaboration to take place. So let's say we have a user Ishan and Ishan likes item A. We also have user Shalaka who also likes item A. Ishan also likes item B. So the simplest definition of collaborative filtering is like we can consider Shalaka and Ishan as similar users and might guess that Shalaka might also like or may like item B. Like that's the simplest you can do. The second base is content based filtering. Like people have specific likings. Some like only Mexican food, some like only Italian food. So we have a user Tane who likes a movie A which belongs to the genre comedy plus action. There is another movie, B, which also belongs to the same genre. So we think that and we will recommend Tane a movie B. Of course in the simplistic form, but yeah. So that's the basis of recommendation engines, like the foundation. Now, what is use? Well, it's always an hybrid approach. You will never have 100% collaborative filtering. You will never have 100% content-based filtering. You will have 40 and 40. Rest 20, Gen AI. So, quick intro to Neo4j. This is from the Matrix movie. We have Neo. 4j because Neo4j was primarily built in Java, but now they have Scala as well. And Cypher is the query language. Just like for RDBMS, like we have SQL as a query language, here we have Cypher. Why Neo4j and who uses Neo4j? Well, Walmart uses Neo4j for serving real-time recommendations since 2013. On the Neo4j website, we can have a bunch of graph database case studies from organizations across the world. Neo4j stores graph data natively. Now, why I am stressing on native? Because there are also non-native graph databases. What non-native graph databases do? They store your data in RDBMS, Cassandra, document-oriented DB, and they give you a graph interface. So you're like, hey, I तो graph के साथ खेल रहा हूँ, but in the behind the scenes it is tables, and that's why it is slow. So Neo4j is like linked list. So you just hop. So this is how a graph is represented in Neo4j. This has a couple of concepts here. First, we have labels. You can think of labels as table names. But the nice thing about Neo4j is like a particular row can belong to multiple tables. Like a row can have multiple labels. Say take the example of Figma. First it was purely for designer. So it might call their users as designers. But then they later added developer support. So another label can be developer. Now there are very few people who are both developers and designers. So those users, their nodes will have both the label developer and label designer. Each user is represented as a node, like each row in your table is a node. Now the columns and their values are just key value pairs. So age, gender, etc. etc. Now we have relationships. There are no messy joins in Neo4j because there are no joins at all. So we have two types of relationships: directed relationship and undirected. Now in Neo4j, actually there is no undirected. Like all relationships have to be directed. This order, like node 1 to node 2 in this order, you can query like that also without specifying the relationship. And the best thing is that relationships can also have key value pairs. So for example, this person sent a friend request to this person. In the property, you can have a timestamp, like when the friendship request was sent. So any questions regarding this? Okay. So let's proceed to a dummy case study. Say there is a restaurant, Neo4j, which is so elegant, so popular that it has its own app, and we have to recommend the dishes when a user opens the app of Neo4j. So let's take a look at some of the problem statements to be tackled. First is like, what does a user generally order? You might also see it as mentioned as frequently ordered by you. The second problem statement is like, once a particular item has been added by the user into the cart, in the past, based on the user's order history, what other items have also been added into the cart, which is also often bought together by you. The third is, once a user has added something, say pizza, into his cart, among all the customers who have ordered pizza, in that specific order, what also has been added. Let's tackle them one by one. First, Neo4j is a schema-less database, but that means it is schema on rail because there is no schema-less. It is either schema on write or it is schema on rail. So Neo4j is schema on rail. And Neo4j is generally not the primary database. Like you will not store all your data in Neo4j. You will store just the data which benefits from the graph structure, usually for recommendations, and you will have some primary database separate where there is RDBMS, NoSQL, anything. Now, when you are designing the data model, it is a best practice to ensure that your data model should be based on the queries to be made. Like first, okay, I have to give the solution to this problem statement. What query I will need? Then you design the data model like that. And it is an iterative process. Like you are not just going to sit one day and yeah, done. It's not going to happen like that. So, problem statement 1, frequently ordered by you. How we might model this? So, what we can do is, instead of just storing like user mail this order and the user order this item, user order that item, and every time having to go through all the orders, we can just define our user. The DB ID is like the database ID of the user in your primary database. The data type is integer. We also have an item which is a food item. Again, the database ID is the key and the integer is the data type, property value. And we define a has order. And we store the counter. This is the kind of pre-aggregation. So you don't have to aggregate every time. So times, like number of times this user ordered this item. Let's take a look at the example. So here we have user Vaishnavi who has ordered pizza 3 times and has ordered nachos 5 times. Now say Vaishnavi opens the app. So what we will do? We will run this cipher query. Now since this is the first cipher query I am showing to you, let me explain it. So you read it from left to right, is simple ASCII. So first we match. What we match? We match a user who has property database ID and the value for the database ID property is 2. we annotate this as U, so we can use it later on. We define a relationship has order, we also annotate it as HO, and this is a directed relationship towards this item, which we annotate I, any item. Then all we have to do is return I, like this item, and the HO dot times. Remember the data model, we have the relationship property times as frequency. We order by frequency in descending order, and we just limit it to 2. So we get database ID 4, frequency 3, database ID 5, nachos, frequency 2. Any questions here? Okay, let's take a look at the second problem statement. Our second problem statement was often brought together by you in the same order. So that's why we need to store that, okay, this item, because I might order an item, pizza today, I might also order it tomorrow. But along with pizza, I might buy nachos today, and along with pizza, I might buy pasta tomorrow. So there needs to be an order concept, which we introduce. So we say that user has made an order, and that order has item, and we keep it this as like this. Let's take a look at an example. So here we have a user client who has made 2 orders. In one order, he ordered pizza and nachos together. In the second order, he just ordered pasta. Now, client opens the app and adds pizza to his cart. Okay, he adds pizza to his cart with the database ID 4, and client's database ID is 3. So we will run this query. We will match client, which is database ID 3, and this is what I like about Neo4j. Just see, we can maintain a big relationship path in line. So we match client, we match all the orders client has made, then from that order we match we find the path, like we find all the paths where that order contains pizza, database ID 4. Once we have that path, we take that order and we find all the other items in that order, and then we just have to count the number of other items as frequency and order by it and limit to get it. Since there is only one, we are getting nachos database ID 5. In how many orders has nachos appear along with pizza? 1. Now let's take a look at third example. Customers also bought. Now we can solve this by the previous data model as well. But what we will have to do, every time we want to recommend using this, we have to go through all the orders, right? And count the frequency. Again, the same concept. We should use pre-aggregation. What we will do, we will define a relationship order along with from item to item co-occurrences. Let's take a look at example. We are using Ajinkya. 2 orders made. In first order, pizza and nachos. In second order, pizza, nachos and pasta. So as you can see, pizza and pasta have been ordered along with each other 1 time. Nachos and pasta 1 time. And nachos and pizza 2 times. And we are storing this as a relationship. So say a new user comes and adds nachos to her cart. What we will do? Okay, so since the new user added nachos to her cart, nachos is what? Database ID 5. So we just say match item DB ID 5, order along with another item, return the another item and the times of this. Order by frequency descending limit 2, which is we get pizza was order along with nachos 2 times and pasta was order along with nachos 1 time. Now this queries which we saw, we are just recommending, right? How do we maintain and create these relationships? So here is the cipher query which we will need to use when we have to create the relationships in bulk. Now there are 2 places where this type of query will need to be executed. First, say that Neo4j was in production for 4 to 5 months, and then the product manager comes and say, or product owner comes, hey, let's add a recommendation engine. The development team spends around 2 months and comes up with a solution. 6 months has passed in total. Now we need to use the 6 months data, right? We have 6 months data in our primary database. So we will need to write a script which will use multiple Python queries, multiple Cypher queries to take that primary database data and project it as a Neo4j database, like create it out of it. That is one reason. The second reason is that, say your Neo4j database goes down and for some reason your data backup also goes down. It is very much useful if you have something that you can recreate your Neo4j graph database from your existing data. So let's explore what this query does. First, we match all the orders. Then we match an item which was item A, which was ordered in this order. We match item B. Now, where ID of item B is less than ID of item B, this ID method will give us the internal node ID maintained by the Neo4j, which is not recommended to use outside. Like we can use within Neo4j, but don't store this ID outside. Why are you using less than symbol here, or why we have query at all? So what will happen, take the example of pizza and pasta. One time the query will match item A as pizza and item B as pasta, and then next time it will be item A will be pasta and item B will be pizza. But they have been ordered along with each other only one time, right? Like we have ordered, one item is pizza, one item is pasta. Item A pizza, item B pasta, second time item B ulta. But we don't want to count it as twice. So that's why we have a hacky way, like where ID of item B is item of A. Merge. What will merge do? It will either match the entire relationship path or create the entire relationship path. Entire. So we'll merge item A order along with item B. Now what this query will do, since we are not specified the direction, first Neo4j will try to find the relationship item A pointed to item B. Then if it does not find it, it will try to find the relationship item B order along with pointed to item A. If it also does not find that also, then it will go ahead and create a relationship item A pointed to item B. So like first search from left to right. If you get it well and good, then search from right to left. If you get it, match, else create, how create, left to right. Now whenever we create, since this is the first time we saw these two products order with each other, on create set order along with times 1. If you already saw this pair previously, on match set increment by 1. Any questions regarding this query? Okay, so we loaded from the data and we created a graph. Now our app is in production. A user came and ordered. Now we also want to take that data like user order into Neo4j, right, for future recommendations. Consider the user having ID 1 ordered 2 items, okay, and the items ID were 8 and 10. So unwind is like a for loop. It will, this is an nested list because so it will take like 8, 10, run this query and then next. So match a user database ID 1, match the first item, so items permu 0, I call it permu because of permutation. Then match another item, again same, merge. First find left to right, if you get good then right to left, if you get good else create left to right. On create set times 1 or increment the counter. But it works only on my laptop, that's enough, right? Let's deploy to Azure. So here is one possible cloud architecture using Azure. Say we have a mobile app there. User opens the app and places an order. Since I like serverless a lot, I will just use Azure function app. When the Azure function app gets invoked, we will normally add all the data in Cosmos DB for the restaurant to fetch and process it, but we are not concerned with that. What are we concerned is that this order needs to be reflecting Neo4j as well for future. So we have set an Cosmos DB trigger which will invoke an Azure function app which will be responsible to use that query which I showed earlier to update to the deployed Neo4j instance wherever it is. This process is generally called change data capture. This is one part. Second part is the user opens the app. We want to serve recommendations. We have an Azure function app which queries this DB and hits the deploy Neo4j and gives the recommendations. Now here are some ways where you can deploy your Neo4j. One way is Neo4j DB, which is Neo4j's database as a service, fully managed cloud database as a service by Neo4j. It can be hosted on all 3 popular cloud service providers, one of them being Azure. Second option is you can go for standalone VM configured with Neo4j Community Edition. Why community? Cost. Third way is like Neo4j Enterprise on Azure Marketplace and Neo4j Cluster on Azure Kubernetes Service. Now, enough with dummy. Let's take a look at a real case study, a social gathering app. So this gathering app, okay, so let's take a case study, look at a case study which was a social gathering app which I worked on. So the idea was simple. User hosts a gathering, people meet, and then hosts a gathering, people meet, and then users say, okay, I met him, he can be a friend, he's definitely a friend, or I want to meet him again, or he's a crush, he or she, depending on the gender. And then henceforth, whenever the user hosts the gathering, he can say, okay, I only want my visibility of my gathering to these affinities. That's why it's an array of string here. So, whenever a user creates an affinity, like marks another user as say a friend, yes. How do we do that? We match the first user, current user ID, match the second user, other user ID, merge it, affinity that has affinity type, probably we are displaying the property value and return affinity. And we play the role of Cupid. If the affinity type is crush, we say mutual crush notification if applicable, current user ID to other user ID. So that's it. Oh wait, bootcamp, right? Where is our machine? Okay, let's take a look at some real code. So this is the function definition of same mutual crush notification if applicable, which takes 2 parameters, current user ID and other user ID. We are doing simple. We are trying to check whether that other user has marked the current user as crush. So we match the other user ID is other user ID, affinity has affinity type crush, current user ID. Then as it is a good practice or a best practice, we do it in a parameterized query way. We define the params, we execute the read, which is by the way a custom function which I will show you. If the result is not equal to 9, result.length is more than 0, we just send the notification. Now for executing read, as you all know, whenever we talk with some database, we need a driver. So we define our driver, Neo4j driver, and we get a session, execute the read as a transaction and return the result. And how we might send the notification, push notification? Well, we can use Azure notification ops. So effectives for you, if you are new to Neo4j, how you can run it, you can check Neo4j's Graph Academy. If you want to practice Neo4j, you can have look at Neo4j sandbox, where you can spin up instances which stay alive for 3 days. They have pre-made datasets as well as blank datasets, like either blank datasets or lots of pre-made datasets for normal graph analytics as well as for data science. If you are interested in certifications, there are 2 certifications available: Neo4j Certified Professional and Neo4j Graph Data Science Certification. If you do the first one, you get a t-shirt. Also, if you do the second one, you don't. If you like to run Medium articles, I highly recommend you to follow Neo4j Developer Blog publication. I am also a writer in Neo4j Developer Blog, and the queries I show you is a part of the blog. So I have written 2 blogs which are published under Neo4j. You can get the code and the presentation which is in the README file of the code via this bit.ly link. You can just take a photo of it, and my socials handle are on Linktree. I am mostly only active on LinkedIn and GitHub. I just not use Twitter so much. In this Linktree, there I also mentioned the blog links. So thank you, Snod. Of course, event organizers, Neo4j Azure, arrows.app, which I use to create these diagrams, these graph diagrams. Overfish for making delicious food. I hope the pizza is as delicious like this. No. And remember the crycash blog in Who Am I section, that engineering exception? Yes, the whole code exists. If you want to look at how you can define, for those who who hate Python, don't look. For others, that property is like getter, and if it is null, I am using an exception, and this is a setter. So yeah. Now, yeah, the blog has finally ended truly. Any questions?